Hi, and welcome to Algebra Examples. I'm Dr. Finch. Let's get into our example for today. We're going to be talking about composition of functions as well as the domain of a function. In this problem, we have two functions that we're working with. The first one is f of x is equal to x squared, and the second is g of x is equal to square root of x. But notice that there's a caveat here for our second function. We only have square root of x if x is greater than or equal to 0, which means our function is not defined when it's less than 0. And we can see what happens if we draw a picture of g of x on an xy axis. What we end up with is a picture that looks like this. And you can see that g of x here does not go past the y-axis, right? It stays on the right-hand side where x is positive. Now what we're going to do is we are going to start off by trying to find a formula for h of x, which is the composition of the two functions. So in this case, we have h of x is equal to f of g of x. So in this case, our function f is going to eat our function g of x. And what we're going to do is we're going to take that g of x and we're just going to substitute that square root of x where we see that. All right, now that we have square root of x in there, notice what we're going to do next is we are going to punch that into our function f. Notice that everything inside the box, inside the x, is squared. So everything that f eats, which we can see as this blue here, is squared. So when we do that for our function here in our formula, f is eating the square root of x, and we square that whole thing. Now, as you may remember, square roots and squareds cancel each other out. If you don't, here's a reminder. X square root of x can be rewritten as x to the 1/2, and we know that we're squaring that. And algebraically, when we have two things like that in exponents, where we have one exponent to another exponent, we are technically multiplying those two exponents, and our 2's are going to cancel out, and we end up with just a lovely little x. Now, notice that the only thing that f can actually eat here is going to be x is greater than or equal to 0. So that means that our function itself for h has to start off with x is greater than or equal to 0. So h of x is equal to x, but only if x is bigger than or equal to 0. Because if we tried to punch a negative number into h, right? Let's do this as an example. Let's say we try to punch -1 into h. That would be into f of g. And we'd punch -1 in there. We'd get f of square root of -1. And all of a sudden, we'd get imaginary numbers popping up. And we want to stick with real numbers. So we're going to stay away from putting negative signs in there. So this is what our domain is going to be. The domain is just a fancy way of saying what kind of numbers can we put into our function. And in this case, it is going to be all numbers that are greater than or equal to x. I hope you enjoyed this and thank you for listening.